2025 A-Level Combined Mathematics Paper 2 Part B, question number 11, Part B. Part A of this same question was discussed in a previous video, link in the top right. Part B of this question has to do with relative velocity and velocity triangles. The question says, a river of breadth A with parallel straight banks flows with uniform velocity u. So the water is flowing with uniform velocity u all throughout the river. It then says the points A, B and C lie on the banks such that AB is perpendicular to the banks and BC is equal to 2A as shown in the figure. So in the figure we can see we have the two banks here, this bank, and we can see AB is perpendicular, and if the distance between the two banks is A, then that must mean that this distance between A and B is also equal to A. Now it then says also that BC is equal to 2A, so the length BC is 2A, and we can see since C is over here upstream, this distance is going to be 2A. So after this it says two boats P and Q begin their journeys at A and B respectively. So P starts at A, Q starts at B. At the same instant, in time, the boats start moving. The boat P travels relative to the water with a velocity of 2 times the square root of 5u in the direction of AC, and the boat Q travels with a speed of root 2u relative to the water in the direction of BA relative to the earth. Now this is important. You'll notice they say the speed is root 2u relative to the water, but when they talk about the direction, they say the direction is B to A, BA relative to the earth. Now this means that this velocity and this direction relative to the earth of BA are not corresponding to the same exact motion. The root 2u is relative to the water, while the direction BA that the boat is actually physically moving is relative to the earth. So this root 2u is not relative to the earth, it's rather relative to the water, but the direction of motion, what's actually happening, is happening relative to the earth. Now given this, it says, sketch the velocity triangles for the motions of P and Q in the same diagram, and then find the velocity of P relative to the earth and the speed of Q relative to the earth, and also find the direction of the velocity of P relative to Q, and hence find the shortest distance between the points P and Q. So for all of this, what we're going to have to do first is to draw the velocity triangles relevant to this situation, and after doing that, we're going to use them in order to find the velocity of P relative to the earth, the speed of Q relative to the earth, and by finding the direction of P relative to Q, as in the velocity of P relative to Q, we can then find the shortest distance between the points P and Q as they travel, or you could say the boats P and Q, as P tries to travel in this direction, but it's going to travel in something like this, because we have extra velocity u from the water, and also B from B, the boat Q is going to start and move up like this. So as they move, if we find their relative velocity, we can then find the minimum distance between the two boats. So that's going to be our final goal. Now when answering a question like this, a good first approach is to first consider the geometry of the situation and then write down every single relative velocity that we know. So in this case, we consider geometry. We have two parallel banks like this. We have a point A on the top bank somewhere over here, let's say. Another point B like this, such that if we consider the line AB, it's going to be perpendicular to the two banks. We have another point C which is somewhere over here, such that the CB distance is 2A and the distance between A and B is simple A. Now additional to this, I'm also going to draw out this line from C to A, and this line is the line along which, of course, the velocity of the boat P starting at A goes along. So considering this geometry, we can see we make a 90-degree right angle triangle with ABC, which means that the hypotenuse is going to be equal to this length squared plus this length squared square rooted. So therefore, if we consider that 2A squared is going to be 4A squared plus A squared is going to be 5A squared, the square root of that is going to be root 5A. So therefore, the hypotenuse CA here is root 5A. Now additionally, I'm going to call this angle here theta, and then given that, I'm going to write down the sine value of theta, the cosine value of theta, and the tan value of theta, since I think that's probably going to be useful. I don't think tan is not going to be used all that much. I don't think it's going to be used. However, sine and cosine of this angle are definitely going to be important, since the velocity of the boat P is in this direction along this way, which we will probably need to break into components of the vertical and horizontal component. So here, if we consider the situation, sine theta is opposite over hypotenuse, which is going to be 2A over root 5A, or 2 over root 5. Cosine theta is going to be adjacent over hypotenuse, which is going to be A over root 5A, or 1 over root 5, and tan theta is going to be opposite over adjacent, which is going to be 2a over a, or just 2. I don't think tan theta is again not going to be useful, but these two will probably be useful. So now, if we start writing down everything that we know in terms of velocities, what I'm going to do additionally is to let E represent the Earth, and I'm also going to say W represent the water in the river. And the reason I'm going to do this is because when we're considering relative velocities as given in the question, we have relative velocities relative to the water in the river and also relative velocities relative to the Earth. So to make this easier, I'm just going to label these two as being E and W, which will make it more easy for us to write down the relative velocities. Now considering this, the first thing that we are told is that the river flows with a uniform velocity u, meaning that the velocity of the water relative to the Earth surrounding it, which is where what we're assuming to be stationary, is going to be u. So relative to the external Earth, the water is traveling at u, and I'm going to take the rightward direction as being positive, so it's traveling at a velocity u in the rightward direction. So I'm going to represent that with the velocity of the water relative to the Earth being equal to u in the rightward direction, like this. Now after that, if we read the question, it then says the two boats P and Q begin their journeys at A and B respectively at the same instant. The boat P travels relative to the water with the velocity of 2 root 5 u. So it's not actually traveling relative to the Earth with this velocity, it is instead traveling relative to the water with the velocity of 2 times root 5 u. So therefore, when I'm writing this down, I write that the velocity of the boat P relative to the water is 2 root 5 u, and considering the direction, it's traveling along the direction of AC, which is this direction, which means if I draw this with the angle theta, it's going to be, if we consider the upward vertical like this, it's going to be like this in this direction, where the angle here is theta. So therefore, this is going to represent the velocity of the boat P relative to the water. Now of course, it's not relative to the Earth, it's only relative to the water. Now additionally, if we keep reading, it then says that the boat Q travels with a speed of root 2 u relative to the water in the direction of BA relative to the Earth. Now here we can see the speed of root 2 u is relative to the water, but the direction of BA is relative to the Earth. So we write them as two separate things. So writing them down, the first thing says that the velocity of Q relative to the water is root 2 u, and we don't know the direction since it's not provided, but we do know the direction of Q relative to the Earth, which is in the upward direction from B to A. So we can see if it's in the BA direction and B is down here and A is up here, it's going to be upward like that. So after that, we don't really have any other information given to us, and we are asked to sketch the velocity triangles for the motions of P and Q in the same diagram. So we need to use all of this information that we have, these sine values, cosine values, and this stuff in order to work out the triangles, and by doing that we can then find the velocities of certain objects relative to the other objects that are not provided in this question. So if we consider drawing this, what we can start with is perhaps the velocity of the water relative to the Earth, since that's common for both the boats P and the boat Q. So considering that, if we go to the next page, we can draw a horizontal line rightward rather, like this. This is going to be representative of the velocity of the water relative to the Earth. So basically, the velocity that the water in the river has relative to the stationary Earth. Oh, it's not really stationary, but we're assuming it to be stationary, and relative to that we're taking all of the other velocities. So therefore, this is going to have a magnitude of u in the vector space, and its direction is going to be rightward like this. Now after that, we consider the rest of it. We also have the velocity of the boat P relative to the water. Now when these two velocities are added, the resulting velocity is going to be the velocity of P relative to the Earth. So if I write that down, the velocity of the boat P relative to the Earth is going to be equal to the velocity of the boat P relative to the water plus the velocity of the water relative to the Earth. And we can use this to draw a vector triangle. So if I go down here and consider a triangle that I'm going to be drawing, I know this value, and I know this value, but I don't know this value. And this value is going to be the resultant of adding these two vectors together. So by that, I can see, since the second vector is w relative to e, this is going to be the end vector, meaning that the end of both of the other two vectors, the velocity of p relative to the earth and the velocity of w relative to the earth, are going to be this point right here, meaning that the resultant velocity is going to look like this. And also I can say that the velocity of p relative to w is going to be like this. So basically, if we consider the points here, this point is representing, this point right here is representing going to earth or relative to earth, this point is representing p, and this point is representing w. So therefore this vector represents w relative to earth, this vector represents p relative to earth, and this vector represents p relative to w. So from what we know, this vector right here has a magnitude of 2 times root 5u. So we have 2 root 5u, and also we know the angle of this vector, but we know it relative to the downward vertical. So if I draw a little vertical like this, and I'm also going to draw the horizontal corresponding to it where they meet up so that I can draw the triangle properly. If I draw this, then the angle here, this angle from the vertical to that line, is going to be theta. So the angle here is theta. So now if we consider the other motion, we have the motion of q relative to w, and we have motion of q relative to e. The motion of q relative to e is vertically upward, meaning that if this point is representative of e, then the q to e vector should be something like this. It should be vertically upward, and it should converge at this point that is correspondent to e. Now considering the other vector we don't know its direction, but we do know its magnitude is root 2 of u, and we also know from vector addition that if you consider the velocity of q relative to e, it's going to be equal to the velocity of q relative to w plus the velocity of w relative to e. Now considering this, since this velocity here, w relative to e, is in this direction, and the final resultant velocity here is in this direction, we can say if the resultant velocity, which is the velocity of q relative to e, is equal to this vector plus this vector, then from the starting point here, which is this point, which is corresponding to q, we must have the vector going like this, and then coming over to this final point here. So therefore, based on the magnitude of root 2u, we can say that this vector here must have root 2u magnitude. So now, if we consider all of the geometry that we have, we can label some of these points, and using them, we can write out these vectors corresponding points in this vector space. So since we've already used the letters p and q for the two boats, let's use r, s, t and so on for each of the points in the vector space. So let's say we call this point here r, and then maybe we call this point here s, we'll call this point here the convergent point t, we'll call this point here u, and we'll call this, we should use capital U, and we'll call this point here v. So now, considering this, if we consider the points and consider the vectors involved, rt, the rt vector is corresponding with the 2 root 5u, meaning that this velocity here, the velocity of the boat p relative to w, is corresponding to that vector, which is the vector r to s. So therefore, I can expand this downward and say this is equal to, and in the vector space I have, for the velocity of p relative to w, r s vector. So we have r to s vector plus the other vector w to e is going to be this vector st. So therefore plus s t vector, and we can also see if this is equal to the st vector, we have the rs vector plus the st vector, which is going to be equal to the rt vector. So therefore the overall vector of p relative to e is going to be rt. Now we can do a similar thing, actually it's pretty much the exact same thing. For the other velocity, we have the velocity of q to e, q to w, and w to e. W to e of course is still st, so we have s to t. But for the other velocity, this velocity here, we need to figure out what we have, and that velocity is going to be this thing right here, u to t. So we have ut vector plus st, us vector in this direction. This is the us vector, I apologize for that, us vector plus st vector, which come together to form the ut vector, which is the final velocity of q relative to the earth, which we don't know the value of, but we know it's in the upward direction, and we can see here ut is in the upward direction. So this is going to be all that we have for this diagram. Now additionally, I'm also going to be labeling two angles. I'm going to label this angle here as alpha, and I'm going to label this angle here as beta. And the reason for that is that alpha and beta will be useful for finding different values that we need to solve this question. Alpha will be useful because if you consider this length right here, this length is rt, and the vector rt is correspondent with the velocity of p relative to the earth, and alpha will be needed to find the components of that velocity. Similarly, beta is going to be useful because beta, the cosine of beta specifically, can be used to find ut. So I'm going to label these two as alpha and beta. I'm going to say let alpha be the angle, and in this case it's TRV, so TRV angle, and beta be equal to SUT angle. Now given this, if we consider what we're asked to solve, we're asked to find the velocity of p relative to the earth and the speed of q relative to the earth. So velocity of p relative to the earth implies both the magnitude and direction, so we need to find the magnitude of the vector corresponding to the velocity of p relative to the earth and its direction, and we also need to find only the magnitude of the velocity of q relative to the earth. So going down, if we consider what we need to find rt vectors magnitude and direction, but we only need to find ut vectors magnitude. We don't need to find its direction because we already know the direction is upward, but we need to find this thing's magnitude and this thing's magnitude and its direction. So out of the two, the easier one to solve is this thing right here, and to solve the magnitude of ut, we can start with beta. So considering beta, since this angle is 90 degrees, the sine of beta is going to be equal to the opposite over hypotenuse, which is u over root 2u, which is 1 over root 2, which is the sine of pi by 4. Now from this I can actually directly say that beta is equal to pi by 4, and the reason I can say this is because beta is somewhere in between. I'll write 0 less than beta less than pi by 2. Beta is some angle in between 0 and pi by 2, and due to this we can directly say if the sine of beta is equal to sine of pi by 4, then beta is pi by 4 or 45 degrees. So the angle here is 45 degrees. Now considering the cosine of beta, cosine beta is going to be equal to adjacent, which is ut, divided by su, which is going to be ut, divided by root 2u, which is going to be also equal to 1 over root 2. Therefore, if we simplify this down, we can see ut is going to be equal to root 2u over root 2, which is going to be u. Therefore, ut is equal to u, and therefore the speed of q relative to earth is equal to that magnitude, which is u, and therefore we've solved our first question. Now for the second part, we need to find both the magnitude and direction, which is basically the velocity of the boat p relative to the earth, which is corresponding to this vector rt. So to find rt, what we can do is use the method of resolving. We know that this rs vector can be broken into two components based on theta, and from that we need to add to the horizontal component u in this direction. So since the horizontal component is in this direction, we need to subtract the value of u in order to get the actual horizontal component here, which is correspondent to the horizontal component of the rt vector. So if we resolve, if we say resolving, actually we can just say resolving. So by resolving, we can find the components of the rt vector in the horizontal and vertical directions. So considering vertically, the vertical component of our rt vector is going to be rt cosine alpha, it's going to be equal to the vertical component of this vector, which is actually in the downward direction. Actually, I'll just flip that around. It's easier if I just flip the vector around and consider rt cos theta in the downward direction instead. So rt cos theta in the downward direction is going to be equal to the vertical component of this vector rs, which is going to be 2 root 5u times the cosine of theta. So 2 root 5u cosine of theta. and in the other direction, the horizontal direction, which we'll take in, actually that one also, RT vector is in this direction, so we actually have to take it in that direction. RT vector in this direction right here, RT sine alpha is going to be equal to, and if we consider the components, we have 2 root 5 u's sine component, sine theta minus u. So we have 2 root 5 u sine theta minus u, which if you simplify these two down, I'm actually going to take this equation a little bit lower so I can simplify the first one first and then the second one. For the first one, we have RT cos alpha being equal to 2 root 5 u times the cosine of theta, which as we found above, which is going to be useful now, is equal to 1 over root 5. So 1 over root 5. And doing 1 over root 5, we can see it's going to be equal to 2u. So RT cosine of alpha is equal to 2u. Now for the RT sine alpha, it's going to be equal to 2 root 5 u times the sine of theta, which is going to be equal to 2 over root 5. So we have 2 over root 5 times 2 over root 5 minus u, which if you cancel these two out, we're going to have 4u minus u, which is going to be 3u. So therefore RT sine alpha is going to be 3u. Now using these two equations, if we square both sides and add them together, we're going to have RT cosine alpha squared, or RT squared cosine squared alpha, plus RT squared sine squared alpha, which is going to be equal to 2u squared plus 3u squared. Now squaring both sides and simplifying, we get RT squared times sine squared alpha plus cosine squared alpha, which we of course don't care about since it's anyway going to be equal to 1, is equal to 2u squared is going to be 4u squared plus 9u squared, which we can see is going to give us RT squared equals 13u squared, meaning that the size of RT, or the length RT, is going to be equal to root 13u. And we can also maybe say here that sine squared alpha plus cosine squared alpha equals 1 to indicate that we know that sine squared plus cosine squared is equal to 1. So therefore, the magnitude RT is equal to root 13u. Now that's not all, we also need to find the direction. So considering the direction, if we take these two equations and we divide them, let's say we call this equation A, we call this equation B, let's say. Then from A and B, A comma B, we derive the first part, A comma B, we derive the first part, and for the second part what we're going to do is to divide B by A, because when we do that we get sine alpha divided by cosine alpha, which is going to be tan alpha, which we can then use to find the angle alpha. So if we do B divided by A, this is going to give us RT sine alpha divided by RT cos alpha, RT sine alpha divided by RT cosine alpha equals, on the right hand side we have 3u divided by 2u, so we can write equals 3u divided by 2u, and then we're going to get tan alpha is equal to 3 over 2, which we can directly use to say that alpha is equal to tan inverse of 3 over 2, because of course the angle alpha is in between 0 and pi by 2. So therefore the tangent of alpha being equal to 3 over 2 means that alpha is directly equal to the tangent inverse of 3 over 2, and hence we have our answer. So now with this, we have found both the magnitude and the direction with this angle of the velocity of p relative to the earth, which means that we can finally say, therefore the velocity of p relative to the earth, which I'm going to write as v of p relative to the earth, is equal to the magnitude is square root of 13u, and the direction is, if I write down the vertical like this, it's going to be in this direction right here, where the angle here is alpha, and I can say where alpha is equal to the tan inverse of 302. I could also of course directly write tan inverse 302 as the angle here, but I think this format of the answer is more structured, so I'm going to write it like this. Root 13u in this direction where the angle here is alpha, where alpha is equal to tan inverse of 302. And hence we finished that part of the question. We found the velocity of q, we found the speed of q, and we found the velocity of p relative to the earth. Now finally it says, also find the direction of the velocity of p relative to q, and hence find the shortest distance between p and q. Now for this, what we're going to do is to write down the velocity of p relative to q in terms of things that we know. To start that, we can write velocity of p relative to q is going to be equal to the velocity of p relative to the earth minus the velocity of q relative to the earth. Now you could write this like this also. You could take this thing to the other side and write that the velocity of p relative to the earth is equal to the velocity of p relative to q plus the velocity of q relative to the earth, but I think it's alright to write like this. So now, considering these two velocities, the velocity of p relative to the earth was what we just found, which if I break into components was in the horizontal direction 3u, in the vertical direction 2u. So we can break this down into components and write that this is equal to 3u in this direction plus 2u in this direction minus, and velocity of q relative to the earth as we found above was u in the upward direction. So upward direction u, which means we're subtracting an upward direction u, which means that if we total these, we're going to get a horizontal 3u, and then for this one, when we subtract an upward u, it's same as adding a downward u. So we add a downward u to this downward 2u, meaning we get a downward 3u like this, downward 3u, and if you add these together, it's going to be equal to the vector in this direction, which I could directly write, but I'm actually going to write it as components instead. 3u and 3u like this. And I'm going to say that this is equal to a total resultant vector, which I'm going to mark with two arrows like this. And this resultant vector is at an angle of, I don't know for now, so I'll just say, let's say gamma. So now from this we can see the tangent of gamma is going to be equal to 3u divided by 3u, which means it's equal to 1. Which is equal to, of course, the tangent of pi by 4, meaning that gamma is equal to pi by 4. Now, I didn't even need to find the magnitude of the resultant, just its direction. So here it's equal to pi by 4, and I should also mention this is because the angle gamma is again between 0 and pi by 2. So therefore, if tan of gamma is equal to some other tan value, then gamma is equal to that value. So we have this. Gamma is equal to pi by 4. Now with this, we can find the closest distance in between p and q when they travel along their paths. How can we do that? We can do that by considering the relative position of p and q and their motion. So here if we have p here, and here let's say we have q. The distance between them initially, this distance is a, but as p moves according to this, it is going to be moving in this direction at an angle of pi by 4. So if I mark down that motion, it is going to look like this. We're going to have the motion of p relative to q like this. So basically q is stationary here and p is moving along this line right here. And this line is at the angle that we derived, which is pi by 4 like this. And given this, the closest that p gets to q is the perpendicular distance of the point q to this line here that we have, which means we're looking for this perpendicular distance right here. This distance, which I'm going to mark with some symbols. Let's say we mark, how can we mark? We've already used PQ, RST, we'll use like the point D. This is point D, this is point E, and this is point F. So the length DE is correspondent with the minimum distance between P and Q. So what we can do is label a bunch of things. This is a 90-degree angle, and this line right here is the motion of P relative to Q, and we can say minimum distance between P and Q is equal to the distance DE here, and we can solve for DE based on the geometry of the situation. So here we have pi by 4. We can see the sine of pi by 4 is equal to DE divided by A. So we can write that sine pi by 4 equals DE divided by A. So since the sine of pi by 4 is equal to 1 over root 2, we can say DE divided by A is equal to 1 over root 2, meaning that the length DE is equal to A over root 2, which you can finally use to say that minimum distance, we can say like, therefore minimum distance between P and Q is equal to A over root 2. and that is going to be the final answer for this question. So we've solved all of the parts of this question, and that's going to be the end of the video. Now finally, let's discuss the marks award for this question. So at the start, when you write down all of the values that you do know, the velocities of water relative to the earth, and P relative to W, Q relative to W, and Q relative to E, each of these get 5 marks each. After that, when you go down and make the two diagrams in the same diagram, the two triangles in the same diagram, for the points S, R, V, T, and all of the values involved, meaning the magnitudes, the angles, all of that, being marked in the triangle SVR, meaning this triangle right here, you get 10 marks. So basically, all of the stuff related to the motion of P, you get 10 marks. And similarly, the motion of Q for the points S, T, and U, and the values in that same triangle, and all of that, everything related to the velocity of Q, you get another 10 marks. So 10 marks of P's motions, 10 marks of Q's motions. Now after that, when you then use it to find the speed of U to be equal to simple U, all of this work gets you 5 marks. And then for the velocity of P, when you derive these two equations or do some other resolving technique to find these two equations, you get 5 marks. When you combine them to get the magnitude, you get 5 marks. When you combine them to get the direction, you get 5 marks. And when you combine them to get the final answer, you actually don't get any marks. You get marks only for the magnitude and direction with magnitude and angle. And then after that, for the final question where you find the relative velocity of P and Q, for finding all of this, all of the work combined, and eventually getting this diagram and using it to find that the distance is going to be equal to A over root 2, like this. For all of this work, all the work up to this point, you get another 10 marks. And that is going to be all for this question. So I hope you enjoyed. If you have any feedback, post them in comments down below. Thank you for watching, and goodbye.